Hello everyone, this is Ashwin here. In this video, we are going to do the project Fake News Detection Analysis. So I'm going to build a LSTM model for this, and this is a classification model. So we are going to find whether the news is fake or genuine. So that is the objective of this project. So we are going to see some various new techniques here because we are going to deal with deep learning project. So it will be completely different from machine learning projects. So the pre-processing steps will be different and the model creation will be different. So we are going to cover all the related techniques here in this video. So first, let's explore the dataset information. So our objective is to develop a machine learning program to identify when an article might be fake news. So that is our objective. So instead of machine learning, maybe I'll just convert it into deep learning. So that's good because we are going to do deep learning only. Now the dataset attributes. First we have ID, so that is like a serial number. Title, the title of the news article, so that is like a subject or the overview. Author of the news article, that is the author who writes the article. And text, the text of the article, it could be incomplete, so that is also there, so we have to keep it in mind. And finally the label. So 1 means unreliable, 0 means reliable. So you can consider 1 as fake news, 0 as genuine news. So that's how we are going to do the processing. And I'm going to only deal with the text. So that is the important part. So we have to analyze the whole news article to check whether the news is genuine or not. So if you just consider the title, means it will be vague. The title will be small, let's say like 10 words. So that is not sufficient enough to identify whether it is a fake news or not. So we are going to iterate through the text, that is the entire article, and based on the contextual information, we are going to identify whether the article is genuine or not. So we have explored about the attributes of the dataset. Now let's import the modules. So we are going to import all the basic modules in a single go. So first import pandas as pd, import numpy as np, import matplotlib.pyplot as plot, and cbond2. So these are some basic graphical visualization modules. And we are going to deal with text. That's why we are going to use a regular expression, that is re, import NLTK, so that is natural language toolkit, and warnings. We don't need some extra warnings. And apart from that, we have to specify matplotlib inline and warnings dot filter warnings. We will ignore all of them. Run this. So it will import all the modules, and after that we will be loading the data set. So let's wait for a while. Okay, I just made a mistake here. This is matplotlib filter warnings. Now the import modules is done. Now let's load the data set. So for the df equals pd dot read csv, I'm going to use only the train data. So if you want to test it, means you have to do the exact pre-processing steps and do the testing, or you can concatenate the data, both train and test, do the pre-processing, and in the end you can predict using the model. So you can use it in both ways. Now let's display the head. Now you can see this is the title, and title contains like few text, and the text contain the whole article, and we have the label. 1 means unreliable, 0 means reliable, and we also have the author. So we don't need these 3 things. So let's also see what is the length of the title and the text. So df of title I'm going to go for the first one. So this is the length of the title. So it's so small. Now similarly, let's go for the text. Now you can clearly see it, right? The text is like so large. So it's so much bigger. I guess it contains more than 500 words, and it also has some new lines, some brackets, commas. So these things we have to remember. So we don't have to filter the numbers, so that represents some meaningful information. Apart from that, we'll be filtering all the punctuations, like here this one, like this apostrophe, and all these other punctuations also we are going to filter it out in a single go. So this is the text, we are going to use it as input, and let's see what is the length of the data frame. So here we have like 2800, and some of the text are also missing. I guess we can't proceed like that. We have to drop some of the null values. Without any text we cannot process that, so we will drop it maybe here. So we have the label and the text, that is the important one. Now I am going to drop the null values. So drop null values. I'm going to drop the entire row if it has null values. So df dot drop now. This is top null values. Axis equals 0, that represents a row, and we can drop the whole thing. Let's drop it. Now let's check for null values or length of the data frame. Now we have around 18,285. That's too less. So author have so many null values, that's why it's dropping so many, but we don't need ID, title or author. Maybe we will drop the unnecessary columns here. Drop unnecessary columns. df equals df dot drop columns. I'm going to drop the ID, title and the author, and this will be axis 1, that is column wise. Now let's load the dataset again to retain the info. Now drop it. Now drop. Now we have around 20,761 samples, so that is reasonable. Now we have to do other pre-processing. Let's leave some space. Now we have to remove special characters and punctuations. So we will do the pre-processing here. Remove special characters and punctuations. So before that, I will just see how the processing goes. So df of, I am going to have it in clean news equals df of text. First we have to lower everything, so this will lower everything, and we can also have that clean news to be displayed. Now it converted all the characters into lowercase, so that's our first step. And the second steps will be removing special characters and numbers. I'm going to transfer all these code in a single line. So maybe we will just move it down. So to remove special characters, df of clean news dot str dot replace we are going to pass the regex here. So I'm going to specify except the characters like A to Z, small a to Z. Okay, I guess this is like a standard operation, so I'll just mention all of them. We already converted into lowercase, so you don't have to mention this, so it's not necessary. And apart from that, we will ignore the numbers too. So these are the ranges. I think this is 0 to 9. 0 to 9. And I'm going to replace it with a space. So that's done. Or shall we replace it completely, like deleting it? So I think that would be much better. But it also will include the space. So maybe let's give it a try. We have to ignore this normal spaces also to avoid unnecessary confusion. If you do like this, it will remove all the special characters. So it's like this. So we have to definitely leave some spaces. So this is the space. Now you can see it's so much clear, and it also removed all the spaces. You should ignore one empty spaces, means we have to think about that. Maybe backslash yes. Let's run this. Okay, now it's better than before. Now I also like ignored a single space. Now you can clearly see it remove the apostrophe and have the complete word. So it's much more better. So we have done the pre-processing in like a single step. So if you know regular expression means, you can do it very easily like this instead of having a bigger function and do the pre-processing separately. This is a good way to do, and it also removed all the additional spaces, so that's better. And you can also see there are some additional spaces like this, like the double spaces. Maybe we can remove that also. And also we have to remove the escape characters, this one. So we will have that. So I'm going to replace the escape characters. So backslash n, I'm going to replace it with the empty string. So that will be done. And after that, I'm going to replace backslash s plus, I'm going to replace with a single space. So we have to retain these values, so we have to do it like this. So currently I'm just showing you how it's working in a step-by-step manner. Now let's display the clean news after that. Okay, now it's much more better. It also removed the additional space, but we are having some spaces here. So this is enough. So you can combine all the things in a single snippet and do the pre-processing, like a pre-processing function you can create it. So I have done it everything here, so you can see it clearly. So I'll just move this upwards itself. So we are not going to have a separate block for the pre-processing. So this is good. So now after that, we have to remove the stop words. So while doing deep learning projects, you can ignore these stop words removal and other pre-processing techniques like stemming, lemmatization. So you can ignore it because it won't impact the result that much, as we are getting the results in a sequence to sequence model. So LSTM is like a sequence to sequence model. So it will try to understand the whole context of the meaning. Still, we are going to do the pre-processing, like removing the stop words in order to do the exploratory data analysis. So remove stop words. Now I'm going to say stop equals stop words dot words English. Before that we have to import it from NLTK dot corpus import stop words. So all the stop words of the English language will be stored here, and based on that we have to remove this from the clean news. So that will be df of clean news equals df of clean news dot apply. So this is a one line function, lambda x. So when you are using apply lambda, so this x represents a single sample from the data frame. So we are going to process the text. So before that, dot join, and in a list word for word in x dot split. So we are splitting the whole article into single words. So this is the word we are iterating, and we are setting the condition if word not in stop. So if the word not present in the stop words means it will be having like a list. So all the words will be in the list, and we are concatenating into a sentence. So this will do all the things. And after that we will have df of ed. So it's trying to iterate all the words in the corpus, so it will take some time. So now you can see we have removed all the stop words. Here there's removed, here also there's removed, like that all the unnecessary stop words are removed, and these are the clean news we are having. This is the original text we have, and this is the corresponding label. Now we have done the pre-processing. Let's jump into the exploratory data analysis. Now I'm going to go for a word cloud. So that is a common exploration we do for text analysis. So visualize the frequent words. So word cloud is enough for data visualization in this project. So I'm going to go for that. First we will display all the words, all words dot join. So similarly, sentence for sentence in df of clean news. So I'm just concatenating all the text, so it will be a one big string. Before that we have to import the word cloud. So for that, from word cloud import word cloud. So maybe I'll just do the importing at the top. So this is the visualization. So model has been imported. Now let's do the processing. Word cloud equals word cloud of, we have to specify the height and width. So I'm going to specify some of the default parameters I have used for the previous project. Random state 42, max font size, it will be 100, dot generate all words. So this is the word cloud data. We have to plot the graph now. Let's plot it. Plot the graph. Plot dot figure, fig size. So usually it will be 15, 9. Now plot dot im show word cloud interpolation equals bilinear plot dot axis off, and finally plot dot show. Let's run this. So this is a bigger one. We will see what is the most frequently occurring words in all the articles. So this is the whole word cloud, and you can see it here. So you can see said, people, one, time, United States, Trump, Hillary Clinton. So all these things are there. So all the data is related to the election. So Donald Trump first, many. So these are the frequently occurring words. You can see it clearly. So similarly, we will filter out positive, like the genuine news and the fake news, and see what are the frequent words. So it's the frequent words for genuine news. So that will be here df of label equals 0. So 0 is the genuine one, right? Yes. So 0 is the genuine one. Let's run this. And similarly, this is for fake news, and we have to do the same here. Instead of 0, this will be 1, and that's done. Let's run this also. So our for the genuine news, we are having American, Trump said, people, Mr. called, United States, president. So all these things are there, but it's not much related. But if you go for sentiment analysis, means you can clearly go for some words that is positive or negative. But in the fake news, we cannot go like that. So these are the ones are genuine. Let's go for the fake. So in the fake news, most of the fake news are on Hillary Clinton, people, Trump, and Donald Trump, time. So these are the fake news. I think most of them are based on Hillary Clinton and Donald Trump. Based on the word size itself, you can clearly see. So you can also do the analysis, like you can dig deep doing some kind of n-gram processing. So you can this is for individual words, like for each word it's showing the size or the frequency. So you can do this for multiple words, like 2 words or 3 words, like that. You can find out what are the frequent sequence are occurring. So I'll just leave it for you. You can search for that, how to do that. So you can do the similar processing and do it. Now the exploratory data analysis has been completed. Now let's go for the input split. So in the input split, we have to do some kind of pre-processing. So now let's do that now. So we are going to do the tokenization of text and padding of sequence. So this is mandatory in order to do the deep learning project, and we are going to use some word embedding model. I'll explain it in detail. So before the input split, maybe I can create something new. Create word embeddings. So that will be much appropriate. First, let's tokenize text. Tokenize text. For that, we have to import a tokenizer. So from keras dot preprocessing dot text import tokenizer. Let's see whether it is working or not. Okay, it has been imported. Now apart from that, we have to import additional modules. Maybe I'll just take the modules in a separate cell. Now again from keras dot preprocessing dot sequence import pad sequences. So this is another thing. Now let's do the tokenization. Initialize it. Tokenizer equals tokenizer. Now tokenizer dot fit underscore on text df of, that is clean news, and after that word index. So this is like a dictionary for us. Word index equals tokenizer dot word index. Now vocab size. So I already told you this is like a dictionary for us. We are going to mention the length of the word index. So this will give us all the unique words in the whole corpus, that is the whole data, and based on that we are having the vocab size. This will be useful for creating the model. So this is one of the attribute, and you can also print the vocab size. Vocab size on this. Now we have around 200,000 words. So that is a big corpus we have. Okay, after this we have to do the padding. So why we need to do the padding? So padding is very important because each text or each article have different number of length. So let's say one article have 200 words, means another article may have around 300 words. So the length of the article differs. So in order to equalize the length, we have to do the padding. Padding means it will add some pads to the end of the text. So it will be like empty strings. So mostly it will be like zeros. So padding data. Now sequences equals tokenizer dot text to sequences. I'm going to use the df dot clean news, and after that we are going to pad the sequences. So pad, okay, we don't have to use the same name. Padded sequence equals pad sequence of sequences and maximum length. Maybe it's better to find out, so I'll just leave it as blank, or I'll just have it as 700. That is the maximum length of the article I'm mentioning. So it's better to go for it's better to find the maximum article length and place it here. So that's the best way to do. And padding equals post. That means after the end of the article we will do the padding. So you can use you can pad previously also, like before the article starts. So that is also possible. Truncating post. So it will truncate after 700 words. So that is like a maximum length of the article I'm specifying currently. So you can also find the maximum length, but I don't think my machine is capable of training that much of huge amount of data. Some articles may contain 1000 words also, but we don't have to process the whole article in order to find whether the news is fake or not. So I guess we can go for 600. That's good. Let's run this. So this will take some time, and after that we have to create word embedding matrix. Create embedding matrix. So this matrix is important for us. We have to use this matrix for the model. So before that, you have to download a file called glove. So that contains vectors of words in 100 dimension. It will contain most of the words, like pretty much all the words in the dictionary. You can also go for higher dimension if you have like lots of data. Currently we have like less number of data, that is 20,000 samples. I already downloaded the glove embedding file, so you can download it using the link in the description, or you can also search it in Google. Now with open glove 6b 100 dimension dot text as f. Now for line in f, we will explore what is inside the embedding matrix, so it will be easier for you. So I'll also add a break statement, so it won't do it for all the lines, so it will take so much time. So first we will get the values. So line dot split. Now I will print the values and this. See, this is the values. So this is the word we are going to have. So for this word, this is the matrix representation or the vector representation. So this is the 100 values we are going to have. Now we don't need this word for our use case, so we are going to ignore that, and remaining values we need to have that. So before that, we have to create embedding matrix. So that's a dictionary. Okay, this is a dictionary. Now after the values, I am going to say word equals values of 0. So this is the word, and coefficients equals np dot as array of values of 1 colon. So I am going to get all the values from the first index, and the data type will be float 32. So this is the coefficients, this is the word, and I'm going to add it to the embedding matrix. Now embedding matrix of word equals coefficients. So that is done, and so the length of the coefficients will be 100. I'll also show it maybe before that. Print length of coefficients. See, these are 100 dimensions. So let's remove this. So this will create the embedding matrix. Okay, sorry, this is embedding index. After that only we have to create the embedding matrix. So we have to create the embedding matrix for the words that are included in our data set. So for that only we are going to do that. Now embedding matrix equals np dot zeros of vocab size, that is the maximum length of the vocabulary, plus 1 comma 100 dimension. So this is the row and this is the column. So that's done, and after that for word comma I in word index that we already created here, that's all the words in our data set, dot items now embedding vector, or you can also say vector, it's your wish. Now embeddings, embedding index dot get word So I'm going to get the vector of that particular word, and if embedding vector is not none, like not equals none, like if the word is if the particular word in the corpus is not present in the embedding index, means it will return none. So at that time we don't have to add it to the embedding matrix. So if the result is not none and we have like the 100 dimensions, means we will add it to the embedding matrix. So embedding matrix of I, that is the index, equals embedding vector. So that's done. We have some error in the glove. Okay, before proceeding I faced an error, like here while opening the glove you have to place this encoding UTF-8, or else it's showing an error, like the character map error, something like that it was showing. And let's run this separately because this is a big process. Run this. So this is creating embedding index. Here we will create the embedding matrix. So the embedding index has been successfully created. It didn't show any error. Now let's go for the embedding matrix. Okay, I think here it was showing some error. Is not okay. Now it's completed. So it's not none. So I just changed the condition. It's not none because we are dealing with an array. That's why it's showing some errors. So it's not none means it will add the vectors. Let's display the embedding matrix. So this is how the matrix looks like. Let's only focus on the first. So all the matrix index are 0. Let's go for 1. Okay. Now here these are the words we are having. So this is the result of the embedding matrix. Like this we will be having the vectors for all the words that is present in the data, that is df of clean news. So the embedding matrix has been created. Now we have to split the data. So padded sequence, that is our input, and df of label is the output. Let's split the input here. Before that, padded sequence of 0. So this is how it's gonna be. So these are all padded values, and here also you can see some of the numbers. So each number is represented an index. So this particular number is represented by a word. So that's how it works. And let's see some other word. All of them are having additional zeros. Maybe I'll just reduce the pad sequence to 500 itself. Run this once. Run this again. Okay, now it's reasonable. We are just saving some space. So like this, the padded sequence are there. Let's minimize this. Now we have to split the data. Let's use the train test split. I hope this works. From sklearn dot model selection import train test split xtrain xtest ytrain ytest equals train test split of the input, that is padded seq, and df of label, that is the output. Test size will be 20%, 0.20. Random state equals 42, and stratify equals df of label. So that's done. Let's run this. Okay. it works. Let's check it once. X train of 0, that is there, and Y train of 0, and the label is also there. So we have done our input split, and the train and testing split is also done. Now we have to create the model. Now before that we have to import few things. So from keras.layers import. Okay, I think in the layers we have to import other things like LSTM dropout, dense layer. So I think that will be enough. Maybe, yeah, that will be enough. And from keras, okay, we also have to import embedding. Okay, now keras import sequential. Okay, I think that's it. Now model equals sequential of list. Now here we will add all the layers. Now embedding of vocab size plus 1, that is the size. This is the dimension 100. Weights equals the embedding matrix, and trainable equals false, and this is our first layer. Before that, let's import it. It's not showing any suggestions for me. Now it will show some suggestions. So this is our first layer, that is the embedding, and the second layer will be a dropout layer, dropout of 0.2. So you can specify the dropout as 0.1 to 0.3. So that is a reasonable range. Sometimes people are using 0.5 also. It depends on the analysis or the use case. So after the dropout, after the dropout, I am going to use the LSTM layer. Now LSTM of, I am going to go for 120. Okay, I'll go for first 64 comma return sequence equals true, and after that another LSTM with, maybe I'll just specify both as 128, so that will be better. So I have specified two LSTM layers now. So the first one will be return sequences, and after that I'm going to go for one dropout, again 0.2, and after that dense layer I can go for 5112, and a dropout 0.2, and a dense layer I'll say 256, and again a dropout. Okay, after this we don't need a dropout. Finally we just need the output, that is one dense layer of 1, activation equals sigmoid. So this is our whole model. Let's run this. Okay, our model has been created. Let's compile it. So model.compile. Here we have to specify the loss, optimizer, and the metrics. So loss equals binary cross entropy. Here we have to specify all the things. Cross entropy, because this is a binary classification. Optimizer equals Adam, and the matrix equals accuracy, and that's done. Now model dot summary, and this. Now you can specify. Now you can see all the layers and how many parameters are there. So these are the trainable parameters. These are the non-trainable parameters. That is this layer. The embedding matrix is like a bigger one. There are like so many parameters are there for the embedding matrix. And apart from that, we have only a few layers. So that's good. Now we have to train the model. Train the model. Now history equals model dot fit. Model dot fit. So X train, Y train. This is the training data. Epochs. I'm going to go for 10 epochs. Batch size equals 128. So if you have a GPU with a reasonable size, means you can go for 256 or 512 also. We will see. Based on that, we will adjust the batch size. So it depends on the batch size. Your training process will speed up. We will also specify the validation data. So that will be X test comma Y test. So that is our validation data, and it should display all the things. So these are the basic parameters. You can also fine tune by specifying the learning rate and all the other things. Let's run this. So it's starting the first epoch. Let's hope it runs without any error. So if you don't do the process correctly, means definitely it will go for an error. So here you can see it is training very slowly, because we have like lots of data. Whenever we are dealing with text data, we have to use a lot of computation power, because we are processing individual samples and also like each in a word by word basis. That's why it's like a bigger data. Currently we have around 20,000 samples. Usually when you go for text, means it will be more than lakhs and lakhs of data. You should have some decent GPU to run all these things. So the training accuracy is almost reaching around 61. So it will take some time to complete all the training process. So I have specified a reasonable batch size. So this is good. Okay, I think the validation, it's not working properly. The training accuracy, that is good. We have to stop this. It's not showing the validation data. So I guess maybe this is a tuple. Currently I have to figure out what is the error. Okay, I'll just change the list into a tuple. I think, let's see whether it is works or not. Okay, now it is working. Instead of a tuple, I just specified it as a list. That's why it's a problem. It's a parameter mistake. I guess we are getting the training accuracy as 64 and the validation accuracy as 69. So I'll just do it for 10 epochs. I guess it will reach a decent accuracy in the end. In the meantime, we have to plot the graph. So here I will get a graph for the loss and the accuracy for training and validation. So I'll just print the accuracy score, like how it improves. So that will be enough for us. visualize the results. Now plot history of accuracy. Now again the same line, but instead of normal accuracy, that is train accuracy, we are going to get validation accuracy. We can specify the title, but it's not necessary. But plot.x label, that will be epochs. Plot.y label, that will be accuracy. So you can specify the legend and show. So plot.show, before that I will specify the legend. Plot.legend. So I will say train and test. So that is done. So using this we can visualize the results for the accuracy. Similarly, you can use this for the losses also. Maybe I'll just copy and paste it, so we have some time, because the model training will take some time. We are reached around 64, 65, 64. It's not improving after that. Let's see. Accuracy, val accuracy, instead of that, loss, val loss. Same epochs, instead of accuracy we will go for loss. Okay, that is done. So we will wait until the fourth epoch. If it's not improving, means I will stop it and change the model. Okay, it is around 62 only, but the val accuracy is oscillating between 69 and 66. Now the accuracy is almost reaching around 70. Still, I'll just stop it because it's taking so much time. Just stop it. I'll just comment this model. So if you want, you can use it later and play around. Similarly, I will create another one. With like a simple model. So I'm going to have the embedding, so that's needed. Dropout is needed. So I'm going to add only one LSTM layer. So I'll remove this. After that, I will have the dropout layer. So I will remove this dense layer also. Now I guess this is good. This is like a small model, I guess. Let's see. Let's run this. I'll increase the batch size to 256. Okay, we have defined it freshly. Let's run this again. Now, because I have increased the batch size from 128 to 256, the number of steps is minimized. So before that, we have seen around 130. Now it's 65 only because of the batch size. You can increase the batch size like 512 in order to decrease the number of steps, but you need to have a good GPU for that. Currently, I'm just running it in my local machine. That's why it's, I have to be limited about this. So let's see whether how the accuracy varies here. I'm getting around 61% the first try. Now the training accuracy increased to 62. It's 67. Okay, let's wait for a while until it completes. Okay, now the training has been completed. Let's visualize the results. Now you can see the accuracy has been increased like dramatically in the second epoch or the third epoch. So this is the number of epochs. It's steadily increasing. So as you can able to see, the training and validation accuracy is keep on increasing, and the losses also keep on decreasing. So that is a good thing for us. and we are not seeing that much of a significant improvement here. It's ranging around 62% to 72% here, and you can also see the validation accuracy gone up to 72%. So it completely depends on your model, how you are going to create the model. So this is one model that I have created before, and this is the second model. So it completely depends on the model. So just play around it and see how the results changes. You can also remove this dense layer and drop out layer. Like this, you can do some changes, play around with it, and see how it varies. So you have to do some kind of trial and error. And also I didn't mention the complete epochs, so you have to train at least like more than 50 epochs in order to get some good accuracy. So that is also there. So try to play around with the model. And that's it, guys. We have covered all the steps involving fake news detection, and we are getting around reasonable accuracy. I didn't push the epochs further. If you push it further, means you will get around more than 90% for sure. And just play around with the model in order to improve your accuracy score. And that's it, guys. I'll see you with a new project.